example, it is stated that a steady current of 2 ampere is passed through a solution containing ions of metal M, and they are in M ions, for 9 minutes. The mass of metal M that is liberated is 0.3552 gram. Calculate the relative atomic mass of metal M, given that M is not the actual symbol of the metal, so it is just a representative of a certain metal. Okay, let us start. Let us write the solution here. Here, let us analyze the data given. Data given. We're given current, electric current. We're given current I. The electric current I is equal to 2 ampere. Also, we're given time t. The time t provided is equal to 9 minutes. Mean 9 minutes is 9 minutes is equal to 9 times 60, so as to get seconds. So it will be 9 times 60, which is 540 seconds. So this is the time given. Another thing we are given, the mass of metal M liberated. Mass M liberated is equal to, the mass liberated is equal to 0.3552 gram. What is asked here? We are asked to find a relative atomic mass of metal M is equal to how much? Relative atomic mass of M is equal to how much? Now, let us choose the method we are going to use for solving this relative atomic mass from this data. Here, we are not given the electrochemical equivalent, and we don't know its relative atomic mass. So, directly, here, the direct formula of Faraday's first law of electrolysis will not be applied, as we can't get the electrochemical equivalent. The only way we have here is to solve by first rebalancing the chemical equation for the reduction of M ions to form M as a metal. Now let us start looking at this equation. It will be at cathode, M ions will gain 2 electrons. We gain 2 electrons. 1 mole of M ion will gain 2 electrons to form M as a metal. M as a metal, as you see here. Now, what next? We can let this balance the chemical equation by using concept of mole. By using mole concept and general idea of stoichiometry, that from the balance the chemical equation, 2 moles of electrons are equivalent to 1 mole of M. As you see, 2 moles of electrons are equivalent to 1 mole of M. Now, from there, we can change this number of electrons into Faraday's and write these moles in terms of mass. You can express moles in terms of mass, and also these 2 moles of electrons in terms of Faraday's. As you know, 1 Faraday is equivalent to 1 mole of electrons. So 2 moles of electrons, 2 moles of electrons are equivalent to 2 Faradays. Let us also rate the moles we have with the mass. How do they rate? Let us see. We say that number of moles is equal to mass over molar mass. Mass over molar mass. Now, here we have 1 mole of metal M. If we have 1 mole of metal M, this indicates that the mass and the molar mass are equal. If they are equal, it is where you can get the number of moles as 1. Now it means that if we let the mass let the relative atomic mass of M be X. It means that if the relative atomic mass of M is X, for it to give us the 1 mole, it means that its mass is equal to relative atomic mass. Now here we say that 2 Faradays are equivalent to X gram of metal M. X gram of metal M, whereby this X is the relative atomic mass of metal M. As we have said that for us to get 1 mole of metal M, it means that the mass of metal M is equal to its relative atomic mass. That is why I have put its relative atomic mass here, X. Now, this is according to the standard balanced chemical equation. Now let us relate it with the data which we have. But before we relate it with the data which we have, let us convert this number of Faradays into coulombs. I mean to charge. Here we are going to have 2 times 96,500 coulombs. As you know, 1 Faraday is equal to 96,500 coulombs. So here, instead of writing 2 Faradays, it is the same as the one who writes 2 times 96,500 coulombs. This will be equivalent to X gram of M. X gram of M. After that, you have to remember this X is the relative atomic mass of metal M. So you have to remember here we are going to relate this equation with the data given. The data we have current of 2 ampere and time of 540 seconds. So to relate these two values into coulombs, it means that we take current times time. So it will be on the left hand side. On the left hand side we have the charge in terms of coulombs. So here we are going to have 2 ampere times 540 seconds, so as to get the charge from the data of the question. Now this will be equivalent to the mass liberated. What mass of metal M was liberated? The mass liberated was 0.3552 gram. Now what next here is we have these values. We can solve the value of X. How do we do? We cross multiplication. We cross multiplication here. After crossing multiplication, we can be in the position of solving the relative atomic mass of metal M, which is given there as X. Now we are going to take 2 times 540 times X is equal to, as you see, 2 times 540 times X is equal to 2, this one, to 2 times 96,500 times this value of mass liberated, 0.3552. After there, let us compute by using a calculator the values on the right hand side and the left hand side. On the left hand side we have 2 times 540. We are going to get 1080 X times X times X. 1080 times X will be equal to, let us compute the data on the right hand side. We have 2 times 96,500,000 times 0.3552. Here we get 68. We get 68. Here we get 60. Here we get 68. 68,553.6. Now, after there, we get X by dividing by 1008 both sides. So we divide by 1008 both sides. 68,553.6. We divide by 1080 both sides, by 1080 both sides. Now we are going to get our x will be equal to 68,553.6 over 1008. Now you have to know this one is going to give us, let us divide, it will be this one over 1080. So we're going to get 63.448. This is approximately to 63.5. This is the relative atomic mass of metal M. So according to this result, it shows that the relative, therefore, the relative atomic mass of metal M is 63.5. 63.5. And this is the solution for example 4. As I've told you before, that in this example we don't have an alternative because we were not given the relative atomic mass so as to calculate first the electrochemical equivalent. So the only approach to use for us to reach to the solution, for us to get this relative atomic mass, is only by balancing the chemical equation first for the reduction at cathode. After there, you can compute by using the idea of mole concept until the end. So after example 4, let us look example 5.